So, Donald, we've talked about different types of cloud migrations, and one of them is the concept of lift and shift. Can you describe what that is and how what some of the factors are?
Yeah, so lift and shift really comes down to two varieties, right? Hey, I have a SQL server, or I have something running a particular Jakarta process, right? And I go ahead and I can either do it one of two ways, a couple mixture ways, but one of two ways. I can rebuild a new VM for it, a new home, and I can put my data and my processes and all the other good stuff that I need on that VM and run it. So I'm essentially rebuilding it, but in a very traditional way, right? It's run on a server. The other way I can do it, and there's a number of options for all of the hyperscales, third party and native ones, from any from any hypervisor you'd think of, where you can actually just run the tools and it will do either a live or offline copy of that, right? And it'll pull that VM into the cloud within a particular VPC and IP range, and it'll do all the heavy lifting for you. It'll do all the file synchronization, the VM conversion, et cetera, et cetera. And that gives you a running, mostly usable VM in most cases. There can be some pitfalls, but for the most part, it gives you a running VM.
So
Same
with
as
that mo
restoring from a backup. That's right.
so with that model, you're really just moving this compute from something that you might control in your own data center up to the cloud.
Yeah, you could think of it like restoring from a backup almost. You just happen to be restoring into the cloud, or if you're used to VMware, for example, with vMotion and other forms of this, it's similar for the live migrations as doing a vMotion. You're just doing it into one of the hyperscales via this tooling.
So in the end, you still have the same application and configuration, so on, that you had when it was in your own environment. It's just now far away.
Yeah, and all the pitfalls that come with that, right? So the most obvious and glaring of which, for many people after they do this, is the licensing. Depending on their licensing parameters, they might find the application, if it's a commercial off-the-shelf application especially, suddenly doesn't run. It's not licensed for that CPU ID, or it doesn't meet some other hostname parameter. Whatever that licensing is based around might suddenly fail. The other more secondary one, and it depends on the application, would be the latency, of course. If all your users are on the West Coast and you're migrated into a European data center in the cloud, you might suddenly see some latency if they're used to a local copy, for example.
And then I assume there's also when you move this way, whatever problems that you had with the application in your own environment, they've just moved to a different place, but they still exist.
But they still exist, and you may so there's one of two things that's going to happen. If you rebuild, if you go with a new nice fresh VM that you've rebuilt from automation or by hand, it doesn't matter. You may forget something, right? So there might be something that a human forgot or automation was left out of, something that was tweaked by hand. And that might have, disastrous consequences, even weeks or months down the road because something was forgotten. And if you don't rebuild, if you do a lift and shift, you're bringing all the cruft with it, right? So, and that all includes any mistakes that you've made, security concerns. Maybe there's something hidden in that system that you really don't want in there. There's a lot of potential problems there. Even just temporary files that people have put there that shouldn't be there from doing troubleshooting 3 years ago or 4 years ago, right? So you find all kinds of stuff on these older systems, referred to as bit rot or system rot, right? So um, you got to be careful in both scenarios. They both have their pitfalls, but different pitfalls.
And do you get an advantage by moving to the cloud in this model, either a cost advantage or even just the ability to throw more horsepower at the problem to make things work better?
Yeah, so the advantages are going to depend on the reason for the migration, right? So, some very large customers might just have a cost advantage, right? They're bringing in 900, 1,000, 10,000 VMs. They're retiring an old data center due to a leaky roof or whatever the case is. That's a very valid transition. Another one might be, hey, I'm bringing in a few very select VMs because I've got to upsize these, right? You can't do horizontal scaling on them for whatever reason. I'm out of capacity. Maybe it's a faulty system, right? So it's going to cost a lot to upgrade the existing systems, but the stability is an issue. There's a number of reasons, but they're very specific. So each application, each customer's reason will be different. Sometimes it'll be cost, but oftentimes it's not. It's some other compelling factor, including the fact that they may actually be doing modernization on some of their apps, but they do have a few legacy components that they're not ready to rebuild or redeploy yet. But they want it all in the same home for various reasons, whether it be management or, hey, it doesn't make sense to keep these racks and racks and racks anymore for these 3 legacy applications because we've modernized everything else, right? And then there's the skill set as well. Frankly, it's just getting harder to find people that are, able and willing to go into a back office data center with 3 racks. It's very easy to find somebody because you can go worldwide, right? To find somebody to maintain your stuff in the cloud. That's just not true when you have a 100 square foot office in the back with a lock and 3 racks in it.
Very good. I think this gives us a lot to think about.